chapter 5, two-port network and the network function. We have divided this chapter into two parts. First is two-port network and second is network function. Both are related to each other, but for our simplicity we have divided into two parts. In first part we have already seen that is two-port, what is a two-port network and the parameter associated with, that is your ZY, hybrid and transmission parameters. Okay, and we have also solve how to find these parameters. Okay, now we will discuss about second part, that is network functions. Okay, before going to network function, as we know that every network is represented by black box. Okay, and the pair of terminal connected to such a black box at which signal may enter and leave is called as a port. Okay, if network having only one port, then it is called as a one port network. If network having two ports, then or two pair of terminal, that is 1 dash 2 dash, it is called as a two port network. This is port 1 and this is port 2. Okay, now the variables associated with each port are voltage and current. Okay, actually one port network are used practically as the load, while two port network are used to transfer the information. Okay, now we will see the in particular in your syllabus, the network function. We have to study the network functions for one port network and two port network. Okay, first of all we will see the network function for one port network. Okay, this is a one port network having the variable v of t and I of t as it is time domain. Okay, now there are the two functions of this one port network. First, there is a functions, that is two variables measured at the same port. That is for one port network are called the driving point functions. Okay, the functions of the your network port, one port network is a driving point function, and there are the two driving point functions. Okay, the first is driving point impedance function and second is driving point admittance function. Okay, now we will see what is meant by driving point impedance function. Okay, see here, for the one port, whatever we are measuring at the same port only. Okay, now the ratio of Laplace transform of voltage at one port to the Laplace transform of current at the same port. Okay, neglecting initial conditions and is called as driving point impedance function. Simply we can say impedance. Okay, that's why Z of S is equal to V of S upon, that is a Laplace transform of voltage to Laplace transform of current. This is nothing but impedance. As we know that what is admittance, that is the reciprocal of your impedance. That's why we can simply write it is nothing but the ratio of current transform at the one port to the voltage transform at the same port. Okay, and also we can write this Y of S is equal to I of S upon V of S. This is nothing but two driving point functions for the one port network. Okay, we will see one example of one port network. Example is, find the driving point impedance and the admittance for the network shown in figure. Okay, now see here is the we have to, first of all we have to transform this network into the S domain. As we know that when we are transforming the network in the S domain, this L will be replaced by LS. That means this will be replaced by 1 into S, that is 1S. This is your resistance will be as it is. This is your capacitor. Okay, this will be replaced by 1 upon CS, that is 1 upon S. Okay, this is your capacitor. Okay, this is your Z1, this is your Z2 and this is your Z3. We have to find the equivalent impedance, we can say. Okay, Z1 is what? 2 plus S. What is the value of Z2? That is 1 upon S. And what is the value of this Z3? That is 2 ohm. This is nothing but the value of impedances. Okay, now we have to find out the equivalent impedance. That's why we will see, we can see these two are in parallel. That's why this equivalent will be Z dash of, we will see the equivalent impedance of this is Z dash S is equal to Z2 S into Z3 S upon Z2 plus Z3. In this way 1 upon S into 2 upon A1 plus S, A1 upon S plus 2. In this way Z dash equivalent of this will get 2 upon 2S plus 1. Same way this and this one are in parallel. Okay, that's why again this Z dash 1, Z dash S and Z1 are parallel. You will get 2 of S plus 1, S into 2S plus 1 plus 2 into 2S plus 1 plus 2. Simply Z of S is equal to 2 into S plus 1, 2S square plus 5S plus 4. Okay, we have get the driving point impedance. Now we have to find the admittance. What is the value of admittance? Y of S is equal to, simply we can also find I of S into upon V of S, or directly 2S square plus 5S plus 4 upon, what is the value? 2 into S plus 2. This is nothing but your we can say admittance value. Okay, this is nothing but the solution. Now second part, the network function for the two port network. As we have discussed, for the one port network there are the two functions, that is driving function. First is your impedance and second is your admittance. But for the network function for the two port, basically there are the two main functions. First is driving point function and second is transfer function. Okay, first driving point function is same as your one port network. First is a driving point impedance function. It is also ratio of your voltage transform at one port and current at the same port. See here, when there is a word driving point, then it is at the same port. If it is transfer, it is from one port to other port. Okay, we will see first driving point impedance function. As we know that for the, this is Z11 and this is Z22. That's why Z11 is equal to V1S upon I1S and Z22 is V2 upon I2. That is voltage transform at one port to the current at the same port. This is very important. Okay, now same as admittance, current transform to one port to the voltage transform at the same port. Same port is very important in the driving point functions. Okay, now for the two port network there is a that is transfer function. Okay, we will see which are the transfer function for the two port network. It is nothing but we can say transfer function is defined as ratio of Laplace of two variables is defined at one port, while other variable is defined at the second port. Okay, there are four functions can be defined for the two port network, or the transfer function for the two port network. First is the voltage ratio transfer function. Okay, this is the voltage ratio, that's why there will be two voltage ratio, but this is the word is transfer function, that's why it is from one port to other port. Okay, that is the voltage ratio is denoted by G of S is equal to, see here, the voltage from second port to the voltage of one port. Okay, that is V2 upon V1. Transform is there, yes, transform. Okay, or we can simply write V1 upon V2. Okay, now second function is current ratio transfer function. Okay, now the ratio of transform of current at one port to the current at other port. When there is a transfer word, there is always one to other, therefore it is denoted by alpha s. We can simply write I2s upon I1s or I1s upon I2s. Transfer function impedance function, transfer impedance function, as we know that impedance is the ratio of what, voltage and current, that's why it will be voltage and current ratio, but it is from one port to other port. Okay, that's why Z21 is equal to V2s upon I1s and Z12 is equal to V1s upon I2s. Okay, then transfer admittance, as we know that admittance is the ratio of current to voltage, but here transfer word, that's why it is from second port to first port, we can simply say, or the one port to other port. Transfer admittance is Y21 is equal to I2 upon V1s, or Y12 yes is equal to, we can simply write I1s upon V2s. Okay, as we have studied in this particular video, that is your there are two types of one port network and your two port network. Okay, this one port network having the function driving point function, it has first is driving point impedance function and driving point admittance function. Okay, and two port network, it has driving point function. First is driving point impedance function, and second is your driving point admittance function, and again second is transfer function. In transfer function there are four functions. First is voltage ratio transfer function, second is current ratio transfer function, third is transfer impedance function, and fourth is transfer admittance function. These are the four functions we have studied. Okay, we will take one example of the two port network. See here, this is two port network. We have to find the Z of S and your T of S. Okay, what is Z of S? V1 upon I1. That's why we will apply KVL. First of all, transform your network in your S domain. This is T domain. Okay, in S domain your V1 will be replaced by V1 of S, I1 will be I1 of S. Then their resistance will be resistor will be as it is 1 upon S, one capacitor, and this will be 2S. Okay, now apply KVL. V1 of S minus 1 into I1 minus 1 upon S I1 minus 2S I1 S is equal to 0. Okay, after simplification you will get V1 is V1 S is equal to I1 S 1 plus 1 S plus 2S. Okay, by taking the ratio, as we know that this ratio means what? Z of S. Okay, Z of S is equal to 1 upon 1 plus S upon 2S. Okay, now the next thing, that is we have get the first answer. Now we have to find the second answer, that is T of S is equal to V2 upon V1. Okay, see here, V2 is what is the value of V2? We can simply write the V2 is equal to I1S into 2S, I1S into 2S. But as we know, but here the value of I1 is unknown. To find out the value of I1 from equation 1, I1 of S is equal to V1 of S upon, we can simply write S into 2S square plus S plus 1. Okay, after the simplification of cross multiplication of this, you will get S upon 2S square plus S plus 1. Okay, therefore V2 of S is equal to, what is the value of I1 of S? S into V1 of S upon 2S square plus S plus 1 into 2S. Okay, therefore T of S is equal to V2 of S upon V1 of S is equal to 2S square upon 2S square plus S plus 1. This is nothing but your second solution. T of S is equal to V2 of S upon V1 of S. This is transfer solution, or we can say simply voltage ratio transfer function. Okay,